Hello, friends. Welcome to Coding Garden. If you're watching this when it is not live, be sure to check the description so you can skip ahead to the main content. In the meantime, we're going to hang out in the waiting room, so I'll see you soon. Hello, friends. Welcome to Coding Garden. Welcome to Web Security Wednesdays. Today, we're going to be focusing on SQL Injection. And the goal is, by the end of the stream, you will be able to laugh at this classic XKCD joke that everyone brings up when you talk about SQL Injection. You will be able to truly understand the nuances of this joke because you will understand SQL injection. So I know the basics of SQL injection, but one thing we're going to do today is run through Try Hack Me. So this is a website that has a bunch of different labs where you can practice doing various security things. They specifically have this free lab called the SQL Injection Lab, and they have various vulnerable websites that we can try to exploit to learn about SQL injection. And one of the things I am excited to learn about is a tool called SQL Map, which I haven't used before. And they are going to talk about it at some point in one of these lessons. Automating exploitation using SQL Map. So SQL Map is an automated tool that can automatically scan a website, figure out where all the potential inputs are or places that are accepting user input, and then try a bunch of different SQL injection attacks. And then if it finds them, it can also run some SQL injection attacks to try and map the database and figure out what tables there are. And then it gives you like a nice little interface where if something's vulnerable, now you basically have potentially full access to the database. So that will be fun to learn about because I have never used it before and people have told me about it, but it'll be fun to learn about. We are going to do some basic SQL injection first and just talk about what it is. And I'll probably spin up a Node.js app just to show you where you might be vulnerable if you're building a backend app with Node. But that's it. That's all. Welcome in, everyone. Good to see you all. Hi. How you doing? It's Wednesday. And is there a Try Hack Me team? Mark just added their team to that. I'll answer a few of the chats that came in. Duckcode is asking, do I give one-on-one tutoring? I currently don't. I've tried it before. I don't necessarily have the free time to do it. But I want to eventually. Eventually, if I have the free time, it would be fun to give one-on-one tutoring. I've done some like one-off stuff. Some people in the Coding Garden community reached out and I've done it. And in the past, I used to have a Patreon tier where I would give you a 1-hour video chat per month. But yeah, right now I don't really do that. And it is Wednesday. It is Wednesday. And welcome in, Mark. Good to see you as well. Cool. Yeah, you all aren't very talkative today. And that's okay. Let's say hi to everyone, and we'll do more stuff. What's the other days of the week? You mean because today is Web Security Wednesday, or because I said I'm busy? But typically, at least the past 2 weeks or 2.5 weeks, we've done Maintenance Monday, where I just refactor stuff and work on old things. It's not as interesting because I'm trying to at least get some stuff done. Web Security Wednesdays, and then Try Day Friday, where I'll try something new. Last week, we tried PHP and Laravel. Week before that, we tried Rust. Week before that, we tried HTMX. And last week on Web Security Wednesdays, we did... What did we do? Cross-site scripting. And the week before that, we did Hack the Box and learned about default credentials on like FTP and Telnet and Redis databases and stuff like that. But yeah, let's say hi to everyone, and then we'll jump right into it. We'll start doing some SQL stuffs. So if you would like me to say hello to you, you can say hi, hello, hello, hey, yo, cheers, greetings, hi, us up, what's up, morning, afternoon, evening, howdy, good day, coding, hi-yo, vohio, or boga, hey. Say any one of those things. I will acknowledge you. Here we go. The first person to say hello, I think again, is Mark Boots. I don't know if you got the first hello last time. What's up, Mark? Welcome in. And yes, sir, good to see you. Hello, Slake. What's up, Milin, and Demerka, and Refactorer, and Yash, and Arian, and Jack, and Yash on both Twitch and YouTube. Very good, very good. What's up, I500IQ and America 2050? Hello, Itakito, and Farshid, and Amitab, and Mart. Good to see you. And Nafto, it's been a while. Welcome in, Nafto. And kind Nutzer name. Hello, hello. What's up, Irasam and Mataclet, and a skillful actor is asking, what ways do you think is super good at learning in public? YouTube videos, Twitter, or LinkedIn? Oh, I don't know. I technically I do learn in public, but I was doing other things before I was learning in public. So I can't recommend. I can't really recommend anything. I think any one of those things, wherever you spend the most time, that's probably the place where you should do it. That's my advice. And what's up, Daddy Ray? It's been a while. Welcome in. And Nick, good to see you. What's up, Cheeses and Riley? What's up, Sparky and Rami? And Soltz and Moshiko and Harsh. Welcome in, everyone. Dzień dobry. Hello, hello. Guten Tag. I don't know how to pronounce that, Kaizen. But welcome in. Is this Afrikaans? I don't think I've ever seen it written out. And Little Bobby Tables with the $1 tip. Thank you very much, Little Bobby Tables. Did you add anything to your message? Yeah, this is actually really funny because, and Matisse, welcome in. Hey, a member of the Live Coders team. Very good. Everyone in the chat should click that link, drop a follow. Oh, it's Dutch. I see. It's Dutch. Okay. Wait. No, he's saying it is. So maybe it's the same in Afrikaans and Dutch. I don't know. But if Streamlabs had been vulnerable to SQL injection, this person's message would have potentially attempted to drop the master database. But they're not, because they're a large platform and they've been around for a while, and they probably already fixed that if they were ever actually vulnerable to it. But this is your first sneak peek at SQL injection. And thank you, Little Bobby Tables. Thank you for the $1 tip. So yeah, let's do some basic stuff. Let's talk about what SQL injection is, and then code up a simple demo. So I did talk about last week that I might do cross-site request forgery, but I couldn't find any good like online labs for it. So I want to create some like local examples to be able to show you cross-site request forgery. But with SQL injection, I am going to take a few moments and set up a local demo just to show you like a Node.js website that's vulnerable to it, and then we'll jump into these exercises where we'll learn more about it. Yeah. SQL injection is still a thing these days. Yeah, so I think that's the thing is, okay, so we'll talk about what is it and how to prevent it. And one way to prevent it is to escape your queries. So what is it? How to prevent it? We're going to talk about escape your queries, and also use a library or ORM which automatically escapes your queries. These typically automatically escape your queries. Yeah, the other option is to just not be involved with backend development at all, run away, go live in the woods, and then you won't have to deal with SQL injection. Okay, so let's talk about what it is. It is a vulnerability in backend codes that allows an attacker to inject their own queries into an existing query. Now, why is this bad? Right? Like, well, why would we want to prevent injecting into our queries? Well, when we build a website, it has various features, and we typically only intend for those specific features to be supported. We have a login page, and we expect that the login page is only going to be used for users to log in. If users could also use that login page to query all the data in our database, regardless of who they're logged in as, that would not be good. And that's the potential kind of vulnerabilities you open yourself up to if you have not protected yourself from SQL injection. Yeah, so prepared or escaped queries. So escape/prepare your queries. I use these terms one and the same, but maybe there's a slight difference here. But we'll show an example of it. Let me actually just spin up a Node.js app, and we'll query a quick little database. So I'm going to use the Create Express API. This is my little Express API starter. And we'll generate an app. We'll install a database driver, and then try talking to a database. Yeah, I mean, actually, these are other great points that I haven't added here. Is run your queries with the minimum needed permissions, because a lot of times in your backend, in people's backend code bases, they will be running all database queries in the context of like a user, a database user that has access to all of the database. But you could create separate users for various queries, or you can make sure that when certain queries are running, you're using a certain database user that only has access to certain things within the database. The other option is stored procedures as well, because I do believe a stored procedure, when you pass an argument into it, the arguments to the stored procedure will be escaped. I think, maybe? It might be database engine dependent, but stored procedures are functions in your database. Now, I don't know if you have noticed yet, and I don't know how good a job I'm doing of it. I am trying not to say or and it's causing me to pause a lot. So you might notice that. That is what's happening, is I'm trying to look at the camera more, and I'm trying not to say or so that's why I keep pausing. All right, stored procedures are functions in your database, and I guess the nice thing about this is because you have essentially I did it right when you guys said I'm doing a good job. Because you have pre-written the SQL code inside of your stored procedure, when you run that stored procedure, there's potentially no way of injecting new code into it because you already have the code as it is when you run that function. Now, is that true? It would be interesting to look into stored procedures and see, do they escape arguments? Yeah. Cool. The pausing is the way, but you'll notice it's hard. It's hard because the thing is, I think I'm so used to thinking, my brain is thinking when I say or and so if I don't say or it's like I can't complete my thought. Yeah, and so this is another good point to note. Prerequisites. SQL, like the basics of the SQL language. You should know how to select. You should know about comments. You should know the basics of how to use SQL to start to understand how it can be vulnerable. My brother was a Microsoft SQL PM and said that there were edge cases where escaping could be escaped. I think Newlines was the example. Fascinating. I haven't run across any vulnerabilities like that. Yeah, and we'll talk about what escaping means. And I want to show some examples so I can really be clear about it. Using parameters will prevent all forms of injection. You should be using that exclusively, unless you need to dynamically name database objects. Yeah. Cool. It's interesting that you note switch to a non-SQL database. Non-SQL databases sometimes are vulnerable to like object injection. So like, let's say you're using MongoDB as your database, and then you're taking a user provided value that is potentially like an object of some kind, and you're not escaping it or stringifying it. You could potentially be vulnerable to NoSQL injection as well. Yeah. All right, let me spin up this example. So we generated an app. Let's start it up. And then I'm going to need to install a database driver. And for that, I think I'm just going to use, is there just like a SQLite I can install? Straight up SQLite driver? I guess we could use connects. Would that be too much to set up? All right, we install SQLite. Yeah, the thing is, I don't necessarily want to spin up a MySQL database or a Postgres database with Docker. We could, but I just want to use a this is the one we want. Node SQLite 3. It has 1.2 million downloads. And then to use it, and we can even do like an in-memory database. Fascinating. Let's do it. Let's do it. So typically, and I'll show you one of the. Do I have that on my list of ways to prevent it? Yeah, using a library in ORM. Right now, we're just going to use the direct database driver. So better SQLite 3? Well, not SQLite 2. SQLite 3. Published 19 hours ago. It only has 353,000 weekly downloads. We'll use the other one. Yeah. I'm not worried about performance here. We're about to demonstrate SQL injection. Okay, so I installed that as a dependency. Let's open up this code base. And let's create an endpoint here. So yeah, we'll just have an endpoint called users, and this is going to return all the users from the database. And so over here in our API, we need to map that to the users route. So we'll import users. And now when someone goes to /users, it's going to run the users API route. Or downloads better? Not necessarily better. It's only one indicator of package's state. Okay. Let's do this. I'll have a user type. They will have a name, which is a string, and an email, which is a string. I guess they'll have a username. These are our users. And our list is going to respond with an array of user. YouTube has too many ads. Can I do something about it? Right now I have ads set to start every 30 minutes. That's the best I can do. I can probably adjust it after the fact, though. Yeah. All right. For now, we're just going to respond with an empty array, because this is where we're going to put our database query. And then we'll start the app back up and make sure we can hit that route. This is broken. We're still importing emojis somewhere. I renamed this route. Import users. Oh, our tests. Our tests, are they importing emojis? API index.ts. Oh, was the file not saved? Here's the thing. I I hid the activity bar, and now I can't see if my my files have been saved or not. What is that thing called? Status bar? It's not the status bar. Tab bar. Oh, it is the tab bar. There we go. So now that tells me if I haven't saved or not. I could use autosave. I don't like autosave because of various reasons. All right, now if I go to API v1/users, we get back an empty array. Let's query our database. So if I look at this library, we can set up the database connection here. And then I'm just going to create a DB file. So in the source folder, I'll call it db.ts. We are going to create a SQLite database. db.serialize. Also, I'll be using import statements. I might have to import the types for this. Yeah, exclamation mark today will let you know what I'm doing. But essentially right now I'm setting up a local example so that we can demonstrate some SQL injection. Can I do horizontal tabs in VS Code? Or do you mean vertical tabs? I don't know. This example is because they're using prepare, right? And we'll talk about that in a second. I just need to see their. Yes, you can drag it. I don't know why I'm spending time on this, but drag it. Drag it here. Oh, do I need to drag it over here? Doesn't matter. Doesn't matter at all. Back to this. I want to look at their docs. I just want to know basically how do you connect to the DB and then how we can run a query. Sets the execution mode to be verbose to produce long stack traces. So I think we'll do that. Does that return an instance of SQLite 3? It does. And then we'll use that in all of our queries here. This is just going to create an in-memory database. I guess I don't want an in-memory database. I want to write to the file system so that way when the server restarts, it keeps all of the values. Valid values are file names. For an anonymous in-memory database, an empty string for an anonymous disk-based database. Let's just see if I can do SQL.db. And Eddie, thank you for the 34 months. Thanks for doing live on both platforms. Now, I no longer need to keep YouTube and Twitch open to have the live chat available. Yeah. Glad to do it. What's up, Hugo? Welcome in, our resident hacker. Okay. Do we need the serialize function? What does the serialize function do? Is this like what do you call it? Where it like a transaction? Do I need to do? We'll see what happens when it starts. Because I kind of just want to do a db.run. Create table user. Username, text, email, text. Now I need like migrations and everything. Okay, I convinced myself. I'm actually going to use connects because I need to create a basic table. So I'm going to use connects. Okay, now that we have connects, we can create an instance. Use Laravel. I guess I could use this as an excuse to use Drizzle as well. The thing is, I guess I need access to raw SQL queries. I probably can do that with Drizzle. Should be listed in the project's dependencies. It is. Let's reload the window. All right, we have connects. We have a database connection. The thing that connects can give us is just like a simple migration to create a table. It's been so long since I used connects. I forgot how to create a migration and create a table and everything. Migrations. Connects init. Oh, with TypeScript? Oh, man. Now it's going to be even more complicated because if I want to run the migration file, then the migration file is going to be TypeScript. Let's see. Okay. We created a connects file. And then that means we don't necessarily need the DB file anymore. Yeah, so this, in development, we're connecting here. I don't need all this extra stuff. It's going to create a file. And then we need to let our tsconfig know about this. And the reason we need the connects file is the command line tool is going to use this file to generate our migrations and connect to the database. All right. Let's let tsconfig know about the connects file. So that should stop complaining. And then we'll run this command to make a user migration. Okay. I guess I should have ran it with TypeScript, though. I'm really excited about SQL injections. The issue is, like, I wish I would have done this before stream, so you're not having to see me do all of this live and I can just demo it. But it is what it is. All right, now we have a migrations folder. It has this, which we'll use to create the table. And we just need to also let the tsconfig know about the migrations folder. I would put it into source, but then I'd have to configure it. I think I'm getting I'm getting a little annoyed as to how much work I have to do to even demonstrate this. Okay, so we've got that. Now we need to make a table. It's true, Shirkum. Most devs very likely will be using an ORM and really won't even be vulnerable to SQL injection or anything like that. Okay, so we are going to return connects.create schema users, an ID column. We'll have username and email. And so when we run the migration, we'll create this table. When we do migration down, we're going to drop this table. Okay. Now I want to run these migrations. Migrate up. npx connects migrate up. That should have ran this file, which then created the user table in this file right here, this dev.sqlite file. So this is a SQLite is a flat file database, so all of our database is going to exist inside of that file, and it should now have a users table inside of it that we can query. So with that, my DB file here, instead of hard coding this connection string, I want to pull in this connection string from this file. So let's do that. So now I'm going to import the connects config from the directory above, grab the connects file, and then I want to pass in the connects config at development. It's doing module.exports equals. I don't like that. Yeah, we want to grab it from process.env, but also, why is it doing this? Would it still work with export const config? Because then we can bring in the config right here. We'll make that more dynamic in a second. I just want to make sure that exporting it in that way would still work. I broke it. So I broke it by doing, by getting rid of this. Can I have both? Okay, I can have both. That's fine. Which means I'm exporting config, but then this is weird that I'm doing both things in there. Yeah, let's actually do that. There should be a SQLite extension that will let us see our database. SQLite, 2.2 million downloads. Maybe you're right, Marza. Let me try the export default after we get this. Explore and query SQLite databases. How's that different from SQLite Viewer? I can't tell. There's no screenshot of what this thing can do. Let's try it. But I think that's another thing to try. If we export default. Is it okay with that? It likes that. Yeah, good call. Good call, Marza. Okay, but over here, I can still do this. And then right now, I don't want to hard code development. I want to grab... I don't know how to I don't know how to toggle the quick actions bar now that I have it completely hidden. Activity bar, actions panel. What's that thing called? I'm really struggling today. I really am. It happens though. Not every day can be a good day. You have missed nothing. You have missed absolutely nothing. I'm taking forever to do anything. Panel? It's not the panel. No, so see, Command B, because I opened the extensions, now that's the only thing. I can't see the icons to open the other one that I want. Is it tab bar? It's all good. Yeah, that's the only way I can get through any of this is just, you know, do my best. Activity bar is hidden. Where is the activity bar? Focus the activity bar. Now go here. What I need to do is I need a .env that has the .env set to development. So in my .env, we have Node.env set to development. And now I can pull that in right here. Do I have a spot where I'm pulling it? I guess I'm not. So I think .env has a config thing. Maybe it's like this. Yeah, so that should read in our env. And then at that point, I should be able to index it in as a process.env.node.env. Now, TypeScript is going to complain. I don't really want to override this type, so I'm just going to TS ignore this. And then contemplate all of my life decisions and potentially switch stacks or find a library that does better .env stuff. Can we just import it directly from there? And then we just invoke it. Cool. Or not. I'm going to go back to this because I don't want to fix that error. All right. Yeah, I just tried that. It didn't seem to work. I'm not going to worry about it because at this point, we should now have a database connection and we can use it in our actual API route. So if we go back over here to our API users, now I want to query the database right here instead of returning just an empty array. So I can say we're going to grab an instance of connects, which is, and we're off to the races. So this file is creating an instance of connects. That's just going to be called DB. So I'm going to import this file, and I should have a connection to the database. So I'll say import DB from DB. And then now I should be able to, well, actually not in here. In here. Now we're cooking. Okay, so now we can pass in the table name. I think I called it user. And I'll just select everything. Select all the things. This will be all my users in the database. And we'll respond with those users. All right, let's see if this works. Okay. SQLite error, no such table user. Good. It's probably because I called it users. Yeah, I called it users. So, query the users table. Also, why did that crash my entire app? I have an error handler. Actually, I guess, oh, you know what? I would need to, I would need to do this to do it right. Otherwise, the whole app crashes. Let's do it right. So actually catch the error, forward it to the error handler, and then now if I do something silly in my queries, it doesn't crash the entire app. There we go. Cool. But now we're querying the database. We're not getting back any users. Let's actually just use the SQLite viewer to put a bunch of users in. So we just installed that. SQLite, open database, that one. And then we have the SQLite Explorer. It shows us all of our tables. And then we can look in the users table. To see that there is nothing. And then this is also saying I can do an insert query. Cool. So insert into users, values. Username, W3CJ, email, this. How do I run it? I don't like this extension. I need like a visual. I need a visual thing. Missing Laravel yet? I'm not. I mean, Laravel would have just been ready to go with all the DB setup. I'm gonna use SQLite Viewer. Yeah, this just gives me like a UI where I can actually like edit it like it's an Excel table. All right, if I right click this, I have no options. Let's reload. SQLite Viewer isn't a thing anymore. I thought I installed it. Oh, you literally just double click on a SQLite file? Yeah, you just open it. Wow, okay. You just open it. Now it treats it like it's an Excel table. Great. So now I have this. Let's try to insert something. I don't want to search. Is it possible to insert? It's only a viewer. Deep breath, everyone. Deep breath. Here's the thing. If we would have used Prisma or Drizzle, they have like a built-in database viewer that can edit and add rows. Mm, You know what? You know what? I'm pretty sure there's an extension for Firefox that can edit SQLite databases. Um, what's up, Oscar? Welcome in. All right. This is a SQLite manager built into Firefox. We can open our file. Here we are. This. All right. Now, if we want users, use Postman for my database. But here's the thing: am I gonna have to type an insert query? I don't want to type an insert query. All right, we're gonna go back in time. We're gonna go back in time an hour, and I'm gonna try using Drizzle instead, because I think Drizzle has. Don't they have like the Drizzle viewer? Yeah, they have Drizzle Studio. I don't want to write an insert statement. I really don't. There was a bar at the bottom? Open. Choose the file. Then what? I don't want a sample. Are we in an advertisement? 5 minutes. I think add is add a new database. Here's what we'll do. We'll just write some database seeds. We're already far enough along. We'll just create a seed. Let's create some user seeds. We also could have created a post route that inserted into the DB, but that's okay. We'll get there. So I'm going to make a seed called users. Great. Now I should have a seeds directory, then users. I'm going to add the seeds directory to my tsconfig. Yeah, exactly. I thought I just added it to my tsconfig. Write an insert statement? I did that wrong, but I'm a hacker. I don't know how to write an insert statement. Actually, I guess as a hacker, I should know how to write an insert statement, but we're here. We are going to insert a username and an email. And then we have another username like Hugo. And their email is hugo@hackerman.com. And then we have Oscar. Oscar@coolguy.org. Great. When we run these seeds, those 3 users are going to be put into our database. So to run the seeds, we run this command. Great. No such table, table name. That works because it needs to be the user's table. Cool. We seeded. Now we should have some users we can query against, and then we'll try for some SQL injection. Okay, so nice. All right, we're returning the users from our database. I'm trying to think where we could potentially be vulnerable to SQL injection. Right now, the system is completely open, right? You can just go to this endpoint and list all users. Yeah, I guess let's say, yeah, if we have a login page, like technically this endpoint shouldn't exist. Let's just say we have a login page where you have to type in a user's email to get logged in. This is a system with no passwords, as long as you know the email you get in. But let's say it's vulnerable and we can just dump all of the users in the system. Yeah, that would be vulnerable. Actually, I think you have a good, yeah, let's just do that. That should be easy enough. Let's just do that, Oscar. Because if we have an endpoint where, let's say we don't have this endpoint that just dumps all the users from the database, let's say we grab the ID from the query parameter. So we'll say ID is rec.params.id. rec.query.id. And then I could say here where ID is that ID. Cool. I have this error message here because ID is undefined, so I should handle that. So I should say if ID, if there was not an ID, we're going to throw a new error, missing ID in query. Cool. So now, in order to get a user, I have to pass in their ID like this. User, and then ID equals 1. That gives me back this user. ID equals 2. And I could also throw like a first in there, so it just grabs the first result. So it's not an array. Yeah. Then 3. And then 4, which is nothing. Okay. We could also handle this too. And then, all right, we're in an ad break. When we come back from the ad break, we're going to SQL inject this. Yeah. Yeah, and so you're seeing right now the fact that we are not vulnerable to SQL injection because, actually I haven't demonstrated it yet, but we're not because we are using an ORM. So yeah, when we come back from the ad, we're going to inject this thing. Cool. Cool. All right, I'll be right back. But thank you, Pizza Detective. Thank you for the sub. I appreciate that. Today is a day, and I do appreciate the sub. But I will be right back. It's okay that you can't hear me. I'm not saying anything important. But we're back. The ads are over. Let's SQL inject this thing. So right now, you're already seeing this actually isn't vulnerable to SQL injection, but let's think about how we might be vulnerable to SQL injection. One thing I'll do is I'm going to enable debug mode on the database right here. And I think I can say debug true. And now in the command line, we'll see all of the SQL queries that are run whenever we make a request here. So right now, I'm making a request to my app where ID is banana. You'll see I'll make that request, and then over here, we can see the actual SQL that was executed against the database. So select star from users where ID equals question mark limit question mark. Honestly, though, I think the first prevents certain aspects of SQL injection if I wasn't escaping. But you'll notice these little question marks here, these are prepared statements where the things that we're binding it to are getting replaced within the query. So ID becomes this value, and then limit right here becomes this value in the actual query that's running against the database. And the reason we're not vulnerable to SQL injection here is because it's not using the user-provided query parameter directly in the query. It's saying bind this value, and that value is going to be escaped to be the value right there on the question mark. So this alone is one way to prevent SQL injection, is use an ORM, because ORMs are typically going to use prepared statements when you're writing queries like this. But let's bust out of the ORM and write a query that would be vulnerable to SQL injection. So if I say user is db. I think I can do raw. Yeah, so db.raw takes in a string, and I can just write some SQL right here. So let's actually just grab this. And now we're just going to throw the user provided value in there like this. So we're saying select star from users where ID is the ID value that was in the query parameter. Now, this should still work. No such column banana. It won't work because I have to wrap it in quotes. So wrap the value that I'm passing in here in quotes, and now it's going to attempt to. Well, yeah, we'll say this. If not user or not user.length. So if the array was empty, not found. Okay, but if I pass in 1, we get it. But if I pass in something else, it says not found. So now the query is working again, but this is where we're vulnerable because we're passing that value directly in. So let's think about how we would hack this. Essentially, what we want to do is we want to break out of this query. And because we're just inserting the user provided value in directly, I could, let's say, like close off the existing query. So if I do like a double quote and then a semicolon, that would say where ID equals nothing. But then let's say I want to dump everything from the database. I'll say or 1 equals 1 because 1 always equals 1. And so that's going to be true, which means this will give me every user in the database. And then if there was anything after that I want to ignore, I'm just going to throw a comment in with a dash dash. And so basically, if I pass in the ID as this, now look what the query becomes. Do I get rid of the semicolon? Maybe I don't need a semicolon, but we'll see. We'll see if I know what I'm talking about. But now basically this is how the query will run. And you'll see that it says, oh, you're totally right. Yeah, I don't want the semicolon because I want it to be part of the select statement. Yeah, you're totally right. But we could say select star from users where ID is nothing, or where 1 is 1. 1 is 1 is always true, which means we're going to get every user in the database. So yeah, you were completely right. We don't want to put that semicolon there because we want the rest of our query to be part of the query. So now, if I pass this in, we have just dumped all of the users in the system. This is a SQL injection attack. Essentially, an attacker might look for all the endpoints in your app that can accept values, and if they're not escaping the queries, you could potentially inject SQL code. Now it gets worse than this, right? This right now I'm just dumping the users in the system. That's bad right now, because before I had to know every ID in the system. You could pretend we're not using auto incrementing IDs, even if the IDs were something like GUIDs or something like that. If this was vulnerable to SQL injection, we instantly just dump all the users from the system. Beautiful. It gets worse though. What if I don't just do this? What if I actually do close off the query? So let me put this in here. Select all users. This is where little Bobby tables comes in, because we can drop this table. We can literally destroy the database if we update this command. So if I close off the previous statement with a semicolon, then I can write whatever I want, and I can just say drop table users. And then let's see what happens. let's see what happens. So I'm gonna run this as my SQL injection attempt, and so this is destructive. This is literally gonna destroy our database. Let's see. Not found. Okay, so the query didn't give anything back, but now let's see what happens if I try to hit the same endpoint and request by ID. If this injection worked, we've dropped the table, and now there is no table to query against, and we should get an error that says the user table doesn't exist. So where user ID equals 42, maybe the injection didn't work. Let's think about this. Maybe I do need the first query. Yeah, the first one failed. Maybe I do need a closing quote. Oh, would that happen though? So do the first one, which returns data, and then after that, drop table users? Let's see. Okay, so it selected all of the users, but now if we try to grab a user by ID, it says not found. No, it's still in there. db.raw doesn't allow multiple queries. That's possible. It should allow multiple queries. Maybe raw isn't that raw? Well, it's only doing one query at a time. Let's look at the connect docs. Oh, you're right. We could look at the logs here. The request comes in. Select star from users where ID equals nothing or 1 equals 1. Drop table users. It ran the whole thing in this case. All caps shouldn't be an issue, right? I would expect we'd have gotten like a SQL error. My table's drop proof. We're gonna drop this table. Remove the last double quote. Yeah, SQL isn't, it shouldn't be case sensitive. Hmm. Raw queries. Connects.raw may also be used to build a full query and execute it. Um, how to execute multiple queries in one run? You'll have to execute them as two statements. Oh, it has to be. Maybe it's in. Is it actually enabled in the settings? Let's see. This was a really old thread though, from 2014. Yeah, so another hack foiled by the ORM. Honestly, I think if I really wanted to have a direct query here, I would have to use the SQLite 3 library directly. I think we've already determined that the reason it's not working is it's not running multiple statements. Is this an undocumented option or is it like an old option? It's a very long thread. Uh, multiple statements. Is this still an option? Yeah. Let's try it with the SQLite 3 library directly. Because you're right. Now that we have the table and the data in the table, let's just do it. So over here, we'll export this from the DB file. We're going to export the raw DB. What is it called? It is the connection.filename. Okay. Let's see. So now that we have raw DB, let's try querying it over here. So we're going to import the raw DB and then exec, and then pass in the string. Does exec return a promise? Probably returns a cursor. Prepare, finalize, each. Yeah, we need to. I want to drop this table. Is it really that hard? db.run is what we want. Does run return a promise? What does exec do? Oh, we can pass a callback. Does run? Run takes a callback. All right. Let's pass a callback. Result and error. When are the migrations run? No, we ran those manually from the command line. Result will be an any. Okay. I just want to see what happens here. Oh, what's happening? Oh, TypeScript's gonna yell at us for all this stuffs. Null and undefined. Runs the query with the specified parameters and calls the callback afterwards. It does not retrieve any result data. The function returns the database object for which it was called to allow for function chaining. It doesn't run any. Do they have an example of select? This is why we use an ORM. What does exec do? Runs all the queries on the supply string. No result rows are retrieved. How would I retrieve? Is that the way to do it, Hugo? Doesn't retrieve. Okay, I want all. There we go. There we go. We're closer. Okay. Now I'm just gonna make this nice and wrap it in a little promise. We do this. We run the query, and then we resolve with the result. But if there was an error, we reject with the error. Great. We will say that this returns a user array. And then result is a user array. It's not null? Error or null? Error unknown. Wait, what? Forget about it. All right. That broke. First try. Select star from users where ID equals that value. If there was an error, we reject it. Oh, I think you're right. Yeah. Well, no, it should be resolve reject. Yeah, it's resolve reject. Yeah. Hey, Jarhead, did you see? I actually answered your question about guitar VSTs. I shouldn't be returning that. Still getting a 500 though. Oh, is it error then result? I think that's the issue. They're in the wrong order. Error result. That's why the type was right. The type was right. I just had it wrong here. Error result. Okay. Oh, you missed it? I think somebody clipped it. If you want to look at my recent clips, someone clipped me talking about guitar VSTs. And then TypeScript shouldn't care about this. Nice. All right. First try. All right. Now that we're using SQLite directly, we should be vulnerable. So like the app works as before. I can request users by ID. But now if I use my carefully crafted payload, we should be able to drop the users table. And this is the point where you start to understand the XKCD comment. Or the XKDC comic of Little Bobby Tables, right? So if they named their son this is right here is a SQL injection, right? So if somebody goes to search their system for a student with this name, if that search box is vulnerable to SQL injection, it's going to drop the students table. And so that is what we're going to do right here, right now. We are going to close off the previous query and then drop the users table. Here we go. All right. It at least returns the users, but now if I try requesting a user by ID, it should just say that the users table doesn't exist. It didn't work. It didn't work at all. Man. Is it cached? Can I not do multiple queries with SQLite? We might have to bust out what Hugo is saying is the SQLite thing. Or sorry, the connects raw thing. We'll do that. This should log stuff now that we're doing verbose. All right, we have to go this route where we do connects raw with connects raw. That'll stop escaping multiple queries. Haven't tested it. Well, we're gonna try it. And Alan, thank you for the resub. Somebody in that thread figured that out. All right, now we're gonna try this. We're gonna abuse connects to try to actually run multiple statements here. Let's make sure that this still just works. So yeah, it still returns users, but now let's drop the users table. It didn't work. $30 months? Wow. Thank you, Alan. Appreciate that. So this is the query that it ran. Am I missing the semicolon? So select star from users where ID equals nothing or 1 equals 1, semicolon, drop table users, semicolon. Yeah, I thought it worked. It worked earlier. It should be a dash dash. SQL comment syntax. 2 consecutive dash characters. And extend up to and including the next new line character. Well, I think what we're showing is that it's actually really hard to bust out of the protections. To bust out of the protections of the libraries that we use. Yeah, who thought it would be so hard to do some SQL injection? Come on. Come on. I mean, I guess I could try it with an extra quote. I thought we tried that, though. Here's one thing we can do though, is if we pull up a database browser and then just try running this query against the database, let's see what happens. Because that could actually be the issue there. Is that's you can't do 2 statements in SQLite? Okay, I have this little SQLite app, and I'm telling it to select star from users where ID equals some value or 1 equals 1, drop table users, and then a comment. Okay. It works here. So this is valid SQL, but both libraries are preventing us from running multiple queries. Bum, bum, bum. And so now that dropped the table. Wait. Oh, do I have to save changes? Save. Yeah, so the query is fine. That's basically what we've determined. If we overwrite our existing DB, moment of truth. No, what is happening? I guess this. I'm not sure how to use this app to actually write to the DB here, but if we would have been vulnerable to SQL injection, the table would have been dropped, and then I wouldn't be able to query it anymore. Let's just go do some exercises. Yeah. So honestly, I think this is a great takeaway. Is use tried and true tested libraries for querying your database, because they're going to prevent a lot of SQL injection attempts. This attempt here is trying to do 2 statements in a row. We're still technically vulnerable to SQL injection right here, and that's because we're not using a prepared query. Now, so this is still vulnerable to like leaking all of our users, right? So, all right, now they're gone. Let me recreate the users. We create the tables, then create the users. No such table users. What? Oh. Great. You know, I think it's been a while since we had a very struggle bus coding garden stream, so it was bound to happen at some point. I think I wasn't as prepared today. I kind of wanted to just wing it, and winging it today did not work as well. Okay, our database is back. We can query by ID, but again, this is still vulnerable to the listing all the users in the database. So we actually are still vulnerable to SQL injection, just not multiple statements, which would potentially be destructive. But to prevent that, we should use prepared statements. And so one thing we can do is use like a question mark. And then if you, after that, pass in your list of arguments that should replace the question marks, then you won't be vulnerable anymore. So if we then pass in the ID here, it should now replace the question mark with the escaped ID. And so now, column index out of range? I have the syntax wrong. I have the syntax wrong. Let's see. Expressions, parameter binding. Oh, no double quotes? Now that I'm escaping it? There we go. Yeah, awesome. Cool. So the lesson here is if you really want to use db.raw and pass in raw queries, if you're using some kind of query builder or ORM, you should at least be using prepared statements, which will escape any user provided input that gets passed into the query here. So this one is vulnerable. Let me show you. Because we're in JavaScript, these backticks are how we do template strings. And so I just have a plain old template string where I'm inserting the value myself. This one is vulnerable. This one is not, because I have escaped that user provided input. Great. Yeah. Oh, see, these are the things that I want to learn about Brooklyn Dev, because there are other various things, because I know like tools like SQL Map, if they can at least find one SQL injection, a lot of times they'll spit out the table map. They'll tell you like, these are all the tables that exist in the database and stuff like that. So they might be doing queries like you're mentioning, like a union query or some kind of like schema lookup query that dumps the table information, so they can make further queries from there. Right now we only have one table though. But yeah. Prepared statements can also be vulnerable if you build your query dynamically using user input. The database gets both query and variables and does the correct things to it when using prepared statements. Yeah, so I mean, that's kind of what we're showing here. Like, this is a prepared statement. It knows that whatever values we pass in here should be escaped. It shouldn't use the raw values there. Okay, how we looking on time? 20 minutes till the next ad break. Let's just get started on Try Hack Me. I think let's do a quick summary of what I was mentioning here. So we talked about the vulnerability. An attacker can inject their own queries into an existing query, and the way that they do that is via some way our app is accepting user input. This app is accepting user input via the query parameter, but this is an API. You could be calling this API from a search box on a front-end website. And in turn, that would still be vulnerable to SQL injection because this API endpoint would be getting called from that front end. So the way to prevent it is to escape or prepare your queries. And so this is essentially how we're escaping the query is by using the mechanism supported by our library if we're using raw statements. I guess what I'll show is when you run a statement or run a query like this is automatically under the hood. This is automatically parameterizing that ID value there. And so this is using the query builder aspect of connects. So it's actually escaping that ID there. So yeah, don't write raw queries, use some kind of ORM or query builder because it's going to do it automatically. But if you have to get down to the level where you're doing raw queries, then you should escape them. And then I don't have an example of this, but this would essentially be you have a function in your database that does the querying. And we could look into this really quick. Is our arguments to stored procedures parameterized or escaped? To see if we would be vulnerable there. Drocha is asking, is there an extension or a linter that could detect this kind of mistake? There are static analysis tools that will scan your code base for potential vulnerabilities. It depends on what programming language you're using because various tools are built for different languages, but there probably exists something that can scan your code and say, hey, you're probably vulnerable to SQL injection right there. I haven't used anything like that, but it probably would exist. Brooklyn Dev is mentioning how to do a union. Escape the query, union all, select. This would append to the list all the other tables in the DB. Let's try it. This would be really fun because if this works, we're gonna see the other the internal tables like connects migrations and stuff like that. So let's go back to this vulnerable query and then try doing this. So close off the query, union all, select one, and name from SQLite master. So SQLite master is like an internal table, and then grab all the table names. Ooh, we've leaked data. So we've leaked the other tables in the system, and so then we could potentially do further queries from there. Yeah, nice job, Brooklyn Dev. Thank you for that. Because if we had other tables like, I don't know, user sessions, other information that in our system or whatever else, this would list all the table names. And now that we have the table names, we could potentially union on those table names to start to select data from the other tables as well. Very cool. Okay. I do want to do a quick search to see is our stored procedures, are they vulnerable to SQL injection? Like, do they automatically parameterize the queries and stuff like that? Ooh, all right. SQL stored procedures, SQL injection. How do stored procedures prevent SQL injection? Stored procedures are a form of parameterized query. The fundamental problem that causes SQL injection is data being treated as the query language itself. In order to prevent this, you have to know the difference between the query and the data. Stored procedures solve this problem by writing the query beforehand with markers for parameters. I see. So the stored procedure itself isn't going to be parameterizing the queries for you, but when you write the query from the stored procedure, you would use question marks to correspond to the arguments to that function. And you could just think of stored procedures as functions inside of your database. Like I could have a stored procedure called select users by ID, where I take an argument, which is an ID, and then the code inside that stored procedure would actually look like this, but the ID would be coming from a function call instead of like this, and then we would be protected in that way. So stored procedures arguments aren't escaped automatically, but you'll be using to reference params and args. Cool. All right. Let me save this code. I'm going to add my SQLite database to my gitignore. Cool. Cool. If you want to take a look at my vulnerable code, it's over here on GitHub. Let's jump into Try Hack Me. But Origin says, love the XSS VOD, love this one. Both might convince some people I know not to invent and use their own anti-cross-site scripting and anti-SQL injection code. It is interesting how the prevention mechanisms for both is just use a well-known library, because it's gonna prevent it for you. Like last time, I think the conclusion also was like, if you're using a front-end library like React or Vue or Svelte, they're going to be escaping that stuff automatically, escaping cross-site scripting attempts automatically. So if you just use those, you're fine unless you really want to break out of them. Same thing with querying databases. Okay, next up, we're going to try this lab over here on Try Hack Me. So and let's read this from Brooklyn Dev before we get into it. So just an FYI regarding stored procedures, while the risk is a lot lower, if the stored procedure is doing some dynamic SQL building, it can still be vulnerable. Yeah, I think that is the conclusion that I arrived at. You still have to use parameterized queries. How do you spell parameterized? Parameterized queries, but that is the convention, so you'll be less likely to do it the bad way. Cool. Oh, if you notice, there's still a red outline. The red was too different from all the other messages, but any message that has this red outline is from YouTube, and then the others have the other outline. This is Thunder Client. We installed this the other day to do HTTP requests. So it's just built into VS Code. You can do all kinds of queries and then inspect the response data. All right, 13 minutes till the next ad. Let's at least try to get our environment up and going and do Try Hack Me. So Try Hack Me has a bunch of different labs. They give you 1 hour of lab time per day. So we'll have to move quickly to try to solve this stuff if we want to stay on the free tier. But the SQL Injection lab has all of these tasks where we can practice hacking sites that are vulnerable to SQL injection. We're going to see different kinds of SQL injection. We're going to learn about tools like SQL Map. Here we go. So on Try Hack Me, the attack box is a virtual machine in the cloud that has all the tools you need to do your hacking. So I'm going to start that. This is the one. Did I already run out of time? I stopped my hack box earlier. Did it not completely stop it? Give me a second. I might not have any free time left. Well, I can't use my local machine because you have to be on premium to use their their VPN or whatever. My attack time is gone. Mm. Mm. Premium is $14 a month. Honestly, we might just go over to Hack the Box because they do have a free tier that we can use. um, yeah, it's $14 a month, but this is what I was seeing in their descriptions of stuffs here. So, access to networks, it says you don't on the free tier. Yeah. Well, can I still start the machine here? Oh, I can use a VPN. Never mind. Never mind. Great. Great. All right, let me set this up. uh, Is it a good idea to prevent SQL injection using a regular expression along with parameterized queries? I would say as long as you're just using a library that is already parameterizing your queries, you don't have to do any weird regular expressions or anything else like that. And honestly, I would avoid it because it's going to be hard to think up all the possible scenarios that you're escaping against. Right now, I am setting up um, my local virtual machine. Give me a second. I see you later, Shirkup. Thanks for hanging out. Great. All right. This is my virtual machine. It's running Parrot OS. I am going to create a workspace in here for try hack me. And we're going to make a directory called SQLI. And this is where all our stuffs for all our notes and everything else for SQL injection are going to be in this folder. Now can I connect to the VPN? So I have that. Here. I'm running into some pointer issues. Here we go. So this machine is running locally. So this is, I just have a Parrot OS machine running, and then I can connect to their VPN from here. Let's see. Mm. Oh, okay. I'm connected. It took a long time to connect, though. But yeah, I'm connected. Great. All right. I have this virtual machine running on my computer. I now have it connected to the VPN, which means I'm connected to this remote network so I can actually access this vulnerable machine. If you're interested in learning about private and public networks and like the basics of how like a VPN might work, I talked about that a couple of weeks ago. You can check out this YouTube video. I did a nice little diagram where I showed like connecting to what's happening like when we're trying to connect to Hack the Box and stuff like that. So check that video out there. We are now connected. Here we go. One thing we can do is just try to ping this vulnerable server, make sure it's up, and make sure we can connect to it, because it says we're on the VPN. We just want to make sure we can access this machine. Yeah, but SQL injection has been a problem for like since SQL web apps and SQL were invented. It's not responding. Let's see if I can hit it on port 5000. So the docs here tell me that if I go to port 5000, I think earlier I tried enabling a proxy server. Let me disable that. It said, well, so once I spun up the attack box, ICMP is disabled. I tested it earlier and it wasn't disabled. I think it's just taking a while for the server that we're attacking to spin up. But basically, they're spinning up this server. It's vulnerable. It has multiple web apps, and they're all vulnerable to SQL injection, and we're going to try to exploit it. I don't think we need to in-map this one. We specifically know, or at least like they're going to tell us what to do in their little walkthrough here. Have I not started the machine? I should be connected. Oh, maybe I'm not connected. Yeah, it is off. I looked at the settings in the Try Hack Me dashboard and it says I was connected. Well, we might have a VPN configuration issue. Yeah, I'll try connecting from the command line. Because yeah, I am not connected. Exit due to fatal error. Cannot IOCTL ton set if. Operation not permitted. Oh, sudo. Sudo? I thought I was running as the root user though. All right. Okay, now we're connected. Apparently the yeah, we're in. We're in. I can ping the server and I should be able to get the web page. Great. Apparently using the UI to connect with an open VPN file wasn't working. But this is what we get. We can see here that if we like launch this challenge, it takes us to a web page, and this is the web page that we want to try and hack. And it's very likely that one of these input boxes is actually vulnerable to not cross-site scripting, to SQL injection. All right, and we're off. We've launched the machine. We can visit the website. Let's go on to task number 2. So this is actually a really great video from Computer File. And it's about SQL injection. So go check it out if you haven't. We're actually in an ad break. I don't know if anybody told me, so I'm going to pause. I'm going to wait for the ad break before we jump back into this. I guess we can watch a minute or two of that video.
There are big companies being hit by SQL injections all the time, still in 2016. And if you mess it up, then all your usernames and passwords are out there on Pastebin or what have you, and it's bad PR, not to mention illegal, Data Protection Act and so on, and it's bad news for everyone involved. And inevitably bad news for the hacker as well, who probably goes to jail. Okay, so I should just preface this by saying that, if you do this, you will go to jail, so really don't, I'm doing it on my own website, which is allowed because I've given myself permission. I sometimes go back and watch older computer file videos because, you know, maybe I came to computer file a bit later because I don't know, maybe I was busy doing something. I don't know. But the reason is, so I go back and I look at these videos, and Tom Scott did a really interesting video on SQL injections, which is exactly right. Okay, so I'm not going to reinvent the wheel by talking about exactly how they work. But what I thought is I'd do some and perhaps demonstrate to anyone who's got an interest in web development just how bad it is if you mess this up. This little pretend shop, I can search for products. Anyone who actually does web development or any kind of design will see immediately this is bad. Okay, we've got a lovely little blue gradient here and just a box. Okay, so I can search for hammer. Okay, and when I do that, I get a couple of hammers up. So I get a claw hammer and a sledgehammer.
Yeah.
Right? And
so he's really just showing the stuff that I showed earlier on his own little website. If I had to make a computer file vid, what would it be on? I don't know, probably like full stack development. That seems to be my thing, is explaining the full stack. All right, we know what SQL injection is. We built our own little vulnerable app. Let's get into it. So specifically though, the website we're going to be attacking, it's I'm guessing here, was written with PHP. So this is how PHP is vulnerable, is they are not parameterizing their query. They're literally taking the value of the posted user value on the form data that was posted to this backend and just inserting it directly into the query. And so if this is vulnerable, we can try just, I guess, logging in as a user that we don't even know the password of, right? So let's imagine that there's an ID and then we need to close off the single quote. We'll then say or 1 equals 1. So that means log me in as any user, because it's going to find the user in the system and then comment out anything else. The account information you provided does not exist. All right. The executed query was this. Actually, so we might need two double quotes. Yeah, I'm gonna hide the drop game because it's making so that I thought that was for closing it. Well, I think I need to do the same thing, but I need to do 2 of them like this. We're in. we've hacked the machine. So because the query that they're executing is like finding the first user in the system that has that matching password and that matching user ID. Because we were able to inject or 1 equals 1, that means log me in as any user. I didn't have to know a username or a password, and I'm in. And this is my flag. So over on try hack me, I have to plug this value in to show that I hacked it. Yada 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 yada. What is the flag for the input string? That's the wrong answer. Do I need the whole thing? What's up, Haru? Nice. What's the flag for SQL injection 2 input box string? All right. Now that we're in the website, there's potentially another place that's vulnerable to SQL injection. Our homepage doesn't have any input boxes. We can go to edit profile. I'm guessing edit profile is also vulnerable to SQL injection. So let's give it a try. Is this a different one? Yeah, well, no, it's not. I bet YouTube gets a lot of or 1 equals 1. Yeah, there might be a specific hack that they want us to do. Let's not skip everything and actually read it. I see. So in their attack, they're using dash dash space dash. So the reason we're using that is dash dash is primarily because of how MySQL handles the double dash comment style. Oh, we need challenge number 2. Good call, Kendall. Good call. So SQL Injection 2, this is a separate challenge. And that's what they want for this one. Okay, cool. Cool. So let's try again. I mean, let's just try our previous attack. Will this work? That didn't work. I'm seeing an extra quote here in the query that was executed. So I might actually do a single quote to close it off. We're in. And so there's our flag. Now, I think it's actually walking us through this to show us that, like, you have to try a lot of different things, because ultimately in the real world, we wouldn't be able to see the backend code, right? Like, we wouldn't be able to see the actual queries that are executed, or we wouldn't be able to see the PHP source code unless we got into the system in some other way. So this is part of penetration testing, is like trying a bunch of different things. And I think what we're going to get to is, yes, SQL map. In the real world, you use an automated tool that like finds all the input boxes on the site and then tries a bunch of different combinations of SQL injections to. In the real world, we do social engineering. Yeah, we just ask for the password. Cool. Nice. Okay, what is the flag for SQL injection number 3? All right, on to challenge number 3. Now, I will say it's kind of easy mode to see the queries that are executed, but let's do our best. Let's just see what comes back. Input fields cannot contain special characters. Okay. That to me looks like a client-side validation, which means what if we don't use the client side? Like, that was an alert that prevents it. So yeah, so can we just use a request tool to send the request instead? Is that what it wants us to do? This challenge uses a GET request when submitting the login form. Ah, I see. So we just go. I see. If I try logging in with a plain old username and password without any extra stuffs, we can see the URL that it goes to. And when I attempted to do this alert box, that's a client-side validation. So basically what we can do is if I take this value and just put it directly in the URL, well, not that. The server side potentially isn't validating this, and it's not going to go through client-side JavaScript, so it might just accept it. It doesn't. Oh, well, you'll notice here that the query needs a single quote, not a double quote. We're in. So we've bypassed client-side validation by just using the URL. Yeah, I think this is like a very contrived example. Exactly. You should never have a login do a GET request. It should be a POST request. It should be on HTTPS. There's a lot of things wrong with this website. All right, challenge number 4. Post injection. Yeah, I think this is going to be similar, except because it's not a GET request, we potentially have to use an external tool. I think one thing we can do, this is just supported directly in Firefox, is if you open up the DevTools here, we can replay network requests and modify the values. So if I persist the logs, make a request with like a valid username and password, we can actually see the post request that happened right here. And we can see that it's sending those 2 values and getting this. And so, again, the protection here is client-side protection. So what I can do is resend this and change the body. So now we can change the data that we're submitting with this post request to be the SQL injection. So let me just copy this. And now this is going to submit that request. Bad request. Ooh, do I have to escape it? Maybe I have to escape it. Yeah, or encode it. Scam warning. Firefox isn't letting me paste into the terminal. Allow pasting. Okay. We'll wrap this in double quotes. All right, this is the value that I want because I need to escape it, I guess. Go. Bad request. Okay, let's read their walkthrough to see how they tell us to do it. Oh, they're using Burp Suite. Okay, so when submitting the login form for this challenge, it uses an HTTP post method. It's possible to either remove or disable the JavaScript or intercept it with Burp Suite. So yeah, I've never used Burp Suite before, but this is a tool for like intercepting and inspecting HTTP requests, so you can like replay them. I was just using Firefox because this actually shows us all of the, what do you call it? It shows us all of the requests that are happening in the browser, so I can modify them. I'm curious why we're getting a bad request here, though. Because in Burp Suite, they're kind of just doing the same thing. They are, I can't see this very well, but it's like they're doing a -1 quote. I guess we need to look at the SQL query that it's running. I'm missing the ampersand? Resend. Send the cookie? No, I'm gonna try it again. Oh, yeah, we do have to escape that. Yeah, all of this should be escaped. Because the equal sign would be interpreted in the like the URL here. Just escape the equal? Let's try that. %3D is equal. I might have to use an external tool. Yeah, you're right, SQL Course. I should be taking notes in general. What's up, Teraflops? Good to see you. Maybe I don't need to replay all of the headers. I would have to start up Burp Suite. That's basically, we might have to do that if I can't get this working. Yeah, if we the issue is with Burp Suite, I would have to set it up as like a proxy in Firefox. Let's see. Doesn't escape the single quote, but the thing is, you can see the request. This is the data it's sending in the request, and everything within the double quotes is coming across. Yeah, I mean, disable JavaScript is one thing, but we might have to. Okay, I think that's what I'll do. I'll disable JavaScript for this, but if we have to do some HTTP intercepting, I'm gonna have to get Burp Suite working. Yeah, this is curious. We could try that. They have -1 quote. -1 quote or 1 equals 1 dash dash. Yeah. I don't know. We'll just disable JavaScript. Actually, I would be curious. When is the... yeah, on submit, I'm just going to remove this. We're not going to validate the form on submit. We're in. But I am curious why the modifying the outgoing request wasn't working. Getting something wrong. Cool. All right. we did part 1. That was fun. All right, now on to part 2. Injection attack on the update statement. If a SQL injection occurs on an update statement, the damage can be much more severe as it allows one to change records within the database. Yeah, so far we've only seen... Oh, actually, good call. Let's see what we were getting wrong. Oh, there's a bunch of plus signs. So they escaped the spaces. Let me see if I can get that working. So yeah, let's modify this one. And then try escaping the spaces. And then did they... How do we encode an equal sign? %3D. All right, that also didn't work. But let's compare it. What's up, Miho? This is the one that worked, and this one failed. We're sending the exact same data. It looks like the D can be lowercase or uppercase, because you can see the encoded response here is showing the equal sign. Look, I'm clicking on these two. It's exactly the same. Maybe the headers are different? Yeah, I used encode URI component. That's what I was thinking. Yeah, headers shouldn't matter. Good call, Brooklyn Dev. Ah. Everything is escaped. We tried escaping everything earlier too, didn't we? All right, let's try it again. We're going to escape everything. But maybe we have to escape it and then use pluses instead of spaces? Escape it and pluses? That's ridiculous. Is that the case? Apparently. Oh, it's like a combination? Okay, %20 is all of the spaces. So everywhere we have a %20 should be a space. Or sorry, should be a plus. All right, let's hope that this works. If this doesn't work, I'm not going to try it again, but it will be good for some peace of mind as to like how their server is interpreting things. Do they explain why? I don't think so. Go. No, that one still didn't work. Try resending the quest and see if it works. Well, we're missing that %27 plus or. Glad to hear it, Zatochi. I appreciate that. Appreciate you saying that. Oh, it didn't escape the single quotes. Why aren't the single quotes being escaped? I think that's why. Why doesn't encode URI component do that? It just returns it as a single quote. What's the code for single quote? I guess I can look at it. %27. Still ain't it. Looks exactly the same. Let's resend this one without changing it. I don't know. It's going to be a mystery. And thank you, Ivo. Appreciate that. All right. On to injecting update statements. All right. The edit page allows employees to update their information. So if we go back onto SQL injection number 5, the update statement. Is this vulnerable? It's parameterizing the login query. Okay, do we have to know who the user is? Was it sending it as part of the URL in the post? Maybe? I don't think so, though. It was supposed to be, it was checked as form data. I don't know. If anybody wants to go try it and let me know, I'd love to hear it because that was really weird that it wouldn't work. I was probably doing something obvious that was wrong. All right, we will now enumerate the database via the update statement on the profile page. All right, all right. How do we log in? I guess we don't log in? It's saying there is a profile page, and then it redirects us back here. We can identify potential column names. See you later, Teraflops. Thanks for dropping in. Get the details from the old tasks. Is it using the same database? The other thing is their passwords are hashed though, so nickname SQL injection. Nickname email. I do know like this is the page that we are trying to hack, but in example 5, I don't know. The login form is not vulnerable to SQL injection because they're escaping the queries. We can see the actual queries that they run. They escape it. And they hash the passwords. Maybe that's possible. If we look at the source of the page, we have login form. That is the only thing on the page is the login form. There is no profile page on here. I gotta be missing something, right? Let me read and not skip over anything. In the employee management application, there is an edit profile page as depicted in the following figure. This edit page allows employees to update their information, but they do not have access to all the available fields, and the user can only change their information. If the form is vulnerable to SQL injection, an attacker can bypass the implemented logic and update fields they are not supposed to. Log in and like the previous... Oh, I can't log in because I don't know the username and password, and this form is not vulnerable to SQL injection. Not keeping my notes? There's nothing in my notes, right? Is there a register? That's a good call. I don't think it did SQL Gortster. Because all of this was just injecting the login page. And then we looked at the dumped data after logging in. And that didn't have any usernames or passwords. I think each of the challenges uses a different database too, or at least a different table. Does it want us to change the field names? Here's the thing. It's talking about at the edit profile page. We are on the login page. So this is making a post request against login. We could modify this to do like a different post request, but I can't. Here's step one. I can't follow the picture because I don't have access to the edit page. It says login form in the picture. This picture says edit admin's profile information. Okay. Down on this page, let's see. All of this assumes you have access to the edit profile page. Tell me I'm wrong. And thank you, Nerdlove. Thank you for the focus mode. Oh, wait. There it is. There's the username and password. I'm telling you. No, see, listen, look. No one in the chat said scroll down to get the login information. Nobody said that. Nobody said that. Maybe somebody did. I don't know. Now that we're in, we can hack this page. Now let's see. So to confirm that the form is vulnerable and that we have working column names, we can try to inject something similar to the code below into the nickname and email field. So if we put this not that. We'll get there. This. So this is going to attempt to inject like a selection of other columns. I think one thing we can do first is just see the query that it executes. And so the query is update user table set nickname equals test, email equals that, password equals that. So yeah, it's absolutely vulnerable because it's not parameterizing these queries. And so what they're telling us to do is to inject this, which would update the email field with without validation. So nickname, set nickname ASD, nickname test, email equals hacked, and then email equals quotes. So it wants us to do it in both of them. Yeah, this I will put in my notes. Challenge number 5. What's up, WMW? And then this will update the email to be hacked. Cool. So what we're realizing is they're not escaping the queries. We can update multiple columns. Cool. Since both fields are updated after injecting the malicious payload, the original SQL statement looks something similar to the following code. With this knowledge, we can try to identify what database is in use. There are a few ways to do this, but the easiest way is to ask the database to identify itself. Identify yourself. Injecting the line with SQLite version into the nickname field shows we're dealing with SQLite. That's fun. Let's do it. Oh, do we have to escape the query? Yeah, we have to escape it. So we'll do like quote, comma, and then nickname equals. Not quite. Quote, comma, nickname equals, comma, email equals. Oh, I didn't mean to submit that. Dang it. Single quote, hacked. So this is going to close off nickname equals, set nickname equals to this, and then set email equals to hacked. Nice. So we have the SQLite version. And basically all this was telling us is you would try all 3 of these things. And if one of them works, then you, first of all, with this one, you've determined that, hey, we're running MySQL, or hey, we're running Oracle, or hey, we're running SQLite. In this case, we've determined that we are running SQLite. And so now we can be more informed about our SQL injection attempts to try to do things specifically that are SQLite specific. Knowing what database we're dealing with makes it easier to understand how to construct our malicious queries. We can proceed to enumerate the database by extracting all of the tables. In the code below, we perform a subquery to fetch all the tables from the database and place them into the nickname field. Cool. So this is saying concat all the table names. Oh, thanks. Right now, we only had 8 minutes left. It would have shut the machine down. But yeah, it has all the table names. And it's selecting them from SQLite master. So this is similar to the injection that Brooklyn Dev showed us earlier, which just like dumps all of the table information. Let's do it. Well, that wasn't it, though. Interesting, they don't do SQLite wildcard, so it ignores the default ones. Let's see. How would I do that? But basically what you're saying is we can update this query so it gets rid of internal tables. It's already in there. And table name is not like SQLI. So yeah, this ignores internal tables. Let's see what we get. So this is going to update our nickname to be a list of all the tables in the database. User table, secrets. There's a secrets table. We can get all the secrets. All right, with that information, can I construct a query that dumps the secrets table? So select star from secrets, but yeah, I think I would do select, yeah, it'd be a subquery. Select star from secrets. This is what it executed. So nicknames equals that. Select star from secrets, email equals hacked, where UID equals 1. Do we have to, did they do something interesting like, oh, group concat. Group concat, maybe? We need some sort of concatenation to get it into a single string. But they might do a further attack to see what are all the column names on secrets, which we could figure out, but I'm just going to read their I'm going to read their walkthrough. Yeah, so extract all the column names from the user table. We can see the only table in the database is called user table. That's not true. We found one called secrets. But this injection will extract all the column names. Secrets. So secrets has a column called secret. So this literally dumped the information for how the secret table was constructed. Okay. So let's see if I can construct my own little thing here, because I want to do group concat on secret from secrets with no where query. So give me all the secrets in the database. We're in. We're in. We got it. There it is. It's really interesting how their walkthrough did not talk about the secrets table. Am I doing a different challenge? Because I'm not doing an update. Is this... Did I somehow get ahead here? What? Yeah, we didn't do it. We didn't inject an update statement. Okay, but we could do that same attack to get the user table. Figure out the other properties. And update account info. That's really what they want us to do here. So the user table has salary. We could increase our salary. That's fun. Passport number. Name. A lot of other things. Okay. By knowing the names of the columns, we can extract the data we want from the database. For example, the query below will extract the profile ID. Oh, I see. It's a walkthrough that tells us like what we could use. The same enumeration demonstrated for finding tables and column names must be done here since the flag is stored inside another table. I see. We're putting a spin on the walkthrough. It's funny that the walkthrough went through like cracking a hashed password though. So yeah, this is a nice little query that's going to take all the data from that user table and then dump it out into our username. It's going to give us hashed passwords. That's why this was interesting to me that, yeah, they're using hash identifier. And then like updating the password. Cool. Cool. All right. Let's keep hacking. Next step. Broken authentication. For task 4? Is this it? We're in. Okay, maybe this is just a. This is a. Did you learn anything in the previous lessons? Can you hear me? Check. Got it. Okay. Broken authentication number 2. Audible. Great. So we're in. Okay, let's see what this tells us. Let's see what this says. So this challenge builds upon the previous challenge. Here, the goal is to find a way to dump all the passwords in the database to retrieve the flag without using a blind injection. Okay, so we could do something like this. First, we want to find all the tables in the database. So we're going to have a query that kind of looks like this. And this is task 5. So, I mean, we can see the query that runs. Its username equals. I don't know if this is going to dump all the table info, though. We have username or 1 equals 1. No, that's not going to dump the table info. I guess now that we're in. Yeah, now that we're in, this is potentially going to be running an update statement, which we can do the attack on. I think. Let's just try it. Not implemented. Notes? Not implemented. Messages? All right, let's try to get back in. We'll try each of these. And here we can say, like, what do they call it? Where note equals this stuff? Yeah, I do wonder why it says not implemented, though. I guess we're also assuming that this is SQLite. It might not be SQLite. Create an account on the login page. Is there a way to do that? Log out. Oh, good call. Thank you, Itakito. Let's try it. So yeah, we don't even need to bypass the login. We can just create an account. Now we have an account. And we're logged in. I see. Maybe this works. Let's see if we can do the injection here to set the SQLite version. So it's inserting these. I'm not seeing them anywhere, though. Read the query when it created the account. Okay. Oh, this I see, because this is our update query, or like our insert query. They are parameterized when you create an account. So these are not injectable. Okay, I don't have any messages. Do I need to create a message? Oh, I didn't mean to log out. Maybe there's a way to create a message here? I don't know. I'm just going to read the walkthrough. Let's see. Before dumping all the passwords, we need to identify places where results from the login query is returned within the application. Yeah, we're not seeing that. That's the one thing we haven't figured out. After logging in, the name of the currently logged in user is displayed in the top right corner. So it might be possible to dump the data there. Okay. There. Data from the query could be stored in the session cookie. It's possible to extract the session cookie and open it in the browser. Do they really want us to modify the session cookie? Huh. What if we sign up as a user? It's a cookie attack. I don't want to do that. I mean, we could, I guess if we have to do it, we'll do it. But if I create a user that has the dump, the SQL injection dump, it's going to display that, right? And Hamida, thank you. That's a lot of gifts. I appreciate that. You are very kind. Thank you. Thank you, thank you, thank you. That's awesome. Okay. All right, we just created a user with that name. Here's the thing. How do we log in? How do we log in as that user without SQL injecting it? Can we escape these? Yeah. How do I log in without? No way. Wait. Are you pressing the right buttons, Hamida? That's a lot of gifted subs. This is 40 gifted subs. Come on. Come on. You're too kind. All right, we might have to do the cookie injection. Yeah. But yeah, if we set our name to be this, well, not that. If we let's create an account where our username is SQLI version. Here's the thing: if we try to log in as SQLite version, then it's going to this won't work because it's vulnerable. Maybe not. Oh, I would have to inject the username there. Escape it. Okay. Maybe this will work. Yeah, that's not going to work because it's now injecting it. All right, we're on an ad break anyways. I'm going to pause. I'm going to pause. And we'll have to do this cookie attack. Which will ultimately change what's displayed in the URL bar here. But yeah, thank you again for all those gifted subs, Hamida. I appreciate that. That's a lot of gifted subs. Thank you. I appreciate it. And all the people that got gifted appreciate it too. It should have been 60. Stop it. Stop it. And what's up, Stony? Welcome in. Yeah, we're hacking today. Cool. All right. We're gonna pause, but this is interesting because they actually are not using signed cookies. Apparently, we're going to be able to look at the cookie value, modify it, construct our own cookie, and then go from there. Stop it. Thank you, Hamida. You're reminding me how broken my overlay is, though, because all of these should actually display who you gifted it to, and it's just an empty message. Well, we should work on that soon. They're not even following. They're also not subbed. They're not following and they're not subbed, but they are the highest gifter in the channel. And I appreciate it. There we go. Thanks for the follow. Yeah. Yeah. All right, ads. 30 seconds left on ads. And thank you. Thank you, Amita. All right. Welcome back, everyone. If you got gifted, congrats. Shouts out to Hamida for that. But it looks like we are going to have to explore this session cookie vulnerability. So if we look in the dev tools, we can look under cookies, and we can see that session has this value. And apparently there's a way to modify this value. Is this just base 64 encoded? Let's try. No. But apparently if it's Flask, we can decode it. It's not quite a JSON Web Token because there's multiple values. Like typically a JSON Web Token, the middle section is really big. This one has a tiny middle section. Yeah. Decode. Look at that. So apparently it's their own way of encoding and decoding it. If I knew what to do here, we could probably figure it out. Or if we knew how they encoded it. Flask by default uses the URL safe serializer. A Flask app uses a secret key to sign the session cookie so that the client can't modify it. The session cookie itself looks like a bunch of random gibberish, but it's actually really trivial to decrypt. See for yourself in the source of this script. The decoded session cookie will show you its raw contents and includes the signature for those contents. I thought that would be the issue though. Like if it has a signature on it, then the server is going to reject that cookie. Decode a cookie. If it starts with a period, it is compressed. So the payload is skip the first character. Yeah, so we're going to want to look at this. The data is split it on periods and grab the 0th one. So grab this section. Base 64 that. Oh, and then we have to zlib decompress it. Okay, so this, if we decompress this is going to give us a JSON object, I'm guessing. Zlib decompress. I don't know how to do that. Is there a way to? Yeah, is there a command line tool I can use? Zlib plate using OpenSSL. I just want to see the decoding happening. OpenSSL, second link on Google. I was on DuckDuckGo though. Oh, online. Well, no, we don't want that. We want to grab the. So we have the first value. We base 64 decode it, and then we uncompress this. Come on. Oh, okay. Grab that. I was splitting it. I think the copy paste between my virtual machine and my local machine is messing up. Okay, so we grab this. We now B2A it. Yeah. I was doing this. It's just my machine was not letting me copy paste these values. String contains an invalid character. What? I don't think it wants the quotes. Doesn't matter. I don't have to do this manually. If I had to do it manually, I'd figure it out. But apparently that's how it constructs the cookie. All right. Let's see. The decoded cookie can be seen below. It's possible to dump the passwords by using a union-based SQL injection. Cool. This goes for the username in the session cookie. By decoding it, we can see that the username has been replaced with the same value as above. Enumerating the database to find tables and columns as we did under task 2. Dump all the passwords. Okay. By injecting the following username code into the username field, all the passwords are dumped. But how am I supposed to log in as that user? It's not going to be a cookie attack, is it? It is a cookie attack? Oh. Literally attempt to log in and then okay, I guess let's try. Jarhead, thank you for the sub. Appreciate you. Yeah, okay. This one really got past me. It's cookie injection, but like I was mentioning earlier, this is a signed cookie. We couldn't forge and create our own cookies. That's the path I thought we were going down, was like, all right, we're going to create our own cookie with like a specially crafted value. But this is signed, so we wouldn't be able to create our own cookie unless we knew what the secret was. So by noticing, yeah, we got the flag. I just want to make sure I understand what happened here. But by noticing that the username from the cookie is being reflected in the rendered page, we can then inject the logged in user's name. I think the drops are running on other screens. So yeah, these drops are actually happening. Like on this screen. Yeah. See, look at all that. I'm thinking in order to update the drop game for not Christmas, we should just remove the snowflake and then leave it as is. Whoa! One line of me just took out a bunch of people. Yeah, that's the next thing I was going to do, Jitesh, is let's see what query ran here whenever we log in. So select ID and username from users where username is nothing, but then select on the or doing a union to get all the passwords from the users table. And then the return value of this becomes the username field. Yeah. That was a pirate software ferret, wasn't it? Got knocked off the tree. Okay. I'm gonna pretend like I mostly understand what's happening here. So it's basically the part that I didn't exactly get is like why is that query being reflected in the username field? Because it's select ID and username from users where username equals this, and I guess this has to do with SQL. Like the return value of this union becomes the username that we're selecting. That's my main hangup is we dump this table, but then why is it put here? And I think that's why, because the result of the group concat becomes the selected username column in the query. Done. Panzer's good. My dog is doing real good. Not that. Yeah, in this case, we didn't even have to decrypt the cookie because it's just displaying the logged in user's name. If we look at the cookie and we throw this into that cookie decoder, it should dump all that info. Like all that info should be inside of it. Yeah, like this. Oh, thank you, Jitesh. That solves it, right? So, it's selecting two things. It's selecting one and the result of that. So the actual query that gets executed, if you look at it, ID is just going to be this value that we passed in here, and then username is going to be the result of concatenating all the passwords. That's the winner. Thank you, Jitesh. That's what was not sticking with me. But not that. Now we can make that user ID whatever we want. Like 42. And if we look at the cookie, the ID of that user will be 42. Wonderful. Wonderful. Okay, I think that's the other thing is like I'm so used to using ORMs and stuff that like I don't. There's a lot of SQL stuff that gets past me. All right, is this where we're gonna use SQL map? Because I want to learn how to. Yes, we're gonna use SQL map. Okay, cool. All right, this is a blind injection thingy here. Here we go. This challenge has the same vulnerability as the previous one. However, it is no longer possible to extract data from the Flask session cookie or via the username display. The login form still has the same vulnerability, but this time the goal is to abuse the login form with blind SQL injection to extract the admin's password. Boolean-based blind SQL injection will be used to extract the password. Blind injections are tedious and time-consuming to do manually, so the plan is to build a script to extract the password character by character. Extract the password character by character. Oh, it's gonna run like multiple queries that each get a single, like a different character from the password. Maybe. The idea is to send a SQL query asking true or false questions for each character in the password. No way. The application's response will be analyzed to understand whether the database returned true or false. In this application, the application will let us know if the response is successful. Wow. So we are literally querying to say, Is the first character in the the admin's password A? Yes. No. Yes. No. And so we just run a bunch of queries that gives us back the password character by character. What? Okay, so as previously stated, we will want to send Boolean questions to the database for each character in the password, asking the database whether we have guessed the correct character or not. Wow. The first argument to substring, so substring is I guess a SQLite function. First argument is the string start and end. Yeah, I turned the drop game off just because it kept getting in the way. We'll turn it on for a second. The character after the equal sign demonstrates the substring returned. Oh, I see. It's grabbing one character at a time. Yeah, so they have some free tiers for Try Hack Me. So they also make it super easy. Like they have a virtual machine you can spin up in the cloud that has all the hacking tools you would need, but you only get 1 hour of that free per day. If you want more, you have to get on their premium. So right now, I'm still on the free plan, but I have just a local virtual machine that has all the hacking tools I need, and then I'm connected via VPN, so that way I can access this machine. But yeah, this site's free to learn. Try Hack Me. Hack the Box is the other one that we've played around with too. All right, the next step will be to enter the admin's password as a substring into the substring function. This can be achieved with the following query. So select password from users, limit 01. The limit cause is used to limit the amount of data returned by the select statement. The first number is the offset, the second is the integer. So we're grabbing the first character of the password? See you later, Jitesh. I appreciate your comments earlier. That really made stuff click for me. You have the Oracle logo on here? Is that the Oracle? That's not the Oracle logo. Oh, it's there. I see it. Right there. I see. Okay, I get what it's trying to tell us. This is like offset and then limit. So if we grab the admin password, we're grabbing the first character. Okay. Wow. Okay. This is a lot of stuffs. Okay, it's injected into the user field. All right. Let's see what happens. I'm right now. I'm just gonna plug it in. I should try to understand what this is doing, but I'm just gonna plug it in and see what we get back. So substring selects password from users as text. I don't know where we got the value from. Is it in the cookie? Oh, this is the one from earlier. I need to just delete this cookie. A true or false response, so guess logged in equals true. Oh! So we guessed the first character to be T, and because it logged us in, we know that the first character in their password is T. Whoa, okay. Okay. So yeah, logs us in. But if we try this and we give it a different first character, like 53, invalid. Wow. Wow. Hey, Varg, you have access to VIP vouchers? This, I will say, this is one of the last challenges that we're going to do today. But in a future episode of Web Security Wednesdays, yeah, it would be fun to do. Yeah, feel free. If you DM me on Twitch, I'll use it, and I'll let everyone know that I got it from you. So yeah, that sounds great. Appreciate that. But okay, let's actually break down what's happening here. To say what this is doing, this is saying select a password from the users table, limit. So the offset is 0, means grab the first user in the database and limit us to 1. So this is just going to grab the first password in the database, which we're assuming is the admin password. And then substring is going to grab the first character in that password. And then the whole expression is going to return true or false because we're testing that character. So cast, this is something we didn't get into earlier, but I'm guessing this is an ASCII code. So we couldn't just run this. It would be ideal if we could just do this, because we're trying to see, is the first character in the password T? But that returns false. But the application will convert the username to lowercase for this challenge. Yeah, which breaks the mentioned approach, since capital T is not the same as lowercase t. So because the way that it's running the query, yeah, okay, I check it out. Oh no, this always happens. Cool, we're back. This is why I have to hide the tree, because it blocks stuff. Check this out. So we tried with capital T, but behind the scenes, it is converting it to a lowercase t, which is why we need this second level of, what do you call it? Second level of casting it. Basically, we're trying to get a capital T in without sending it as a capital T. And the way that we do that is with ASCII codes. So the cast method is built into SQLite. It allows us to cast various values. I'm guessing it potentially works with more than just ASCII codes, but 54 is the ASCII code for the capital T. If we, in JavaScript, tried to just grab the ASCII code for capital T, it's 84. Shinbo, thank you for the prime. That is not 54. Is it the lowercase value? No, that's 116. Oh, we need hexadecimal. Okay. The hex representation of ASCII T is 0x54 and 0x74. To deal with this, we can input our character as a hex representation via the substitution type X and use SQLite's cast expression to convert the value to the data type the data expects. Okay, so 84 in hex. Is 54. there's multiple levels. So we have capital T ASCII code is 84. 84 in hex is 54. And we are taking the hex value of 54 and casting it as text, which is going to convert it to the capital T. So all of that to say, the result of this expression is either true or false. Is the first character in the password capital T? Yes or no? And if it is, we have our answer. Now, we could do this all day, right? We could go over here. We could run this query over and over again to say, so now we know the first character is T. Now we need to guess the second character. Is it A, B, C, D? We'd have to run a bunch of queries. And that's where automated tools are going to come into place. And basically, we combine this with our injection attempt. So select, we have to basically escape this query to get it to run. And what we figured out is if this results in true, then it logs us in. But if it results in false, then it doesn't log us in. So you could imagine we just send tons and tons of requests. We're brute forcing it to figure out all the characters of the password. Anytime we get a successful response, we know it is a character of the password. Fascinating. If the application responds with the 302 redirect, then we found the password's first character. To get the entire password, the attacker must inject multiple tests for each character in the password. This is so cool. We're learning to hack, everybody. This is fun. It's fun to think about like all the ways to exploit such like a simple vulnerability, right? Because by default, this vulnerability, like it doesn't actually like it does let us log in, but it's not dumping any information from the system. But by brute forcing it, we can try a bunch of different stuff. So yeah, basically we gotta loop it. We gotta loop it. And they give us an example script written in Python. I guess it would be fun to rewrite this in JavaScript. Do we have Node.js on the system? We do. Version 12. Why do we have version 12 on Parrot OS? That's really old. Is it supposed to be? Cool. Yeah, the counter to this is, yeah, you have rate limiting. You prevent someone from making this many requests to your backend app. I see. So here's another addition to this attack is we need to figure out how long the password is. So select the password and check the length. And we can check the length multiple times to figure out the length. Once we've figured out the length, then we can do the attack to figure out every single character. An alternative way to solve this challenge is using a tool such as SQL Map. All right, I want to use SQL Map. I don't want to just use like a Python script, which is an open source tool that automates the process of detecting and exploiting SQL injection flaws. The following command can be used to exploit the vulnerability with SQL Map. So we do SQL Map, give it a URL, give it some data, give it a level, a risk, tell it what kind of database it is, and then a technique. I'm guessing like the technique and everything else is kind of like built into SQL Map. It can be annoying to work with. Yeah, I'm guessing like figuring out what all these command flags are is probably the annoying part. But they're giving us the command. Let's just run it. And so in my VM, I do have SQL Map because we have Parrot OS here. So let's try running it. I was doing Hack the Box, and they recommended Parrot, so that's why I'm using it. It seems fine. It seems fine. We told it that it was SQLI. Why is it trying all these other queries? It is recommended to perform basic union tests if there is not at least any other potential technique found. Do you want to reduce the number of requests? No. Just send all the requests. Got a 303 redirect. Do you want to follow it? No. Injection not exploitable with null values. Do you want to try with a random integer value for option? Yeah. I thought we did force the backend database. DBMS SQLite. Yeah, let's quit because for some reason it didn't take our command line flag. Yeah, I put that on a new line for some reason. Okay. This should just do it. It's doing something. Checking if the injection point on post parameter is a false positive. Post parameter username is vulnerable. Do you want to keep testing the others? No. Fetching number of tables for database. Running in single thread mode, that's fine. We have one users table. I guess it's going to attempt to just dump the users table. If this takes too long, actually, C. Is it going to give us one thing at a time? Yeah, this tool is doing all the work for us. So there are a bunch of common brute force and injection attacks that people have documented and scripted, and SQL Map will let you do those. So potentially, if it has figured out the right vulnerability, it's just going to dump out the password for us. What is happening here? It's getting one character at a time. Wait. It's getting one character at a time and figuring out what the schema is. So it's using this. So I guess we could be more specific with it, but right now it's using this kind of injection attack to dump the table schema. Fascinating. Here it goes. One character at a time. Yeah. Not gonna lie, SQL Map and Hydra are two tools that forced me to learn to do things manually out of frustration when I was starting out. Yeah, I could imagine where maybe if you don't know enough about scripting or whatever else, you just use these tools blindly. But once you know that you want to try a specific targeted attack, you just write your own script to do it. And I think that's what we're gonna do here, because this is gonna take a while. There's probably some other flags I could pass in to tell it exactly what we're trying to do, but here will be something interesting. Let's rewrite this Python script with Node.js. Let's port this to Node.js and then run it. Though they are running Node.js version 12, so I actually don't know what's supported and what's not supported. Brute force admin pass.js. All right. Here's our Python quotes. Actually, let me call this .py just so I can get some syntax highlighting, and then I'll create a JS file. This is hosted within the vulnerable machine, but I can put the codes on gist really quick. Yeah, you can find that over here. Well, thanks, Varg. I find it fun. It's honestly not as popular as the other stuff I do because people are here to like see web dev, but I'm having a good time. All right. We need a URL. Let's have a function that says that is. We'll just call this attack. This will run the attack. The URL that is vulnerable is this. It's here. We're going to be sending a post request here. We somehow know that the password length is 38. We could write code that figures out the password length, though. Not the most efficient way of doing it, but let's convert this. Also, let's see how our attack over here is doing. Oh, it already found it found it. So it dumped the user's schema, and then now it's gradually dumping the users table, and it found the flag for us. But this will be fun. We'll actually write some code here. Let's actually get this working with Node.js. So we want a loop that goes up to the password length. And then for every character in string.ascii lowercase, is this a set of all lowercase ASCII characters? I'm not super familiar with Python, but I think that's what it's doing, right? So it's creating a string that has all lowercase letters, uppercase letters, and digits. So we'll have to build that up ourselves. Get all hex codes. So start off with none, and then we want from lowercase a to uppercase a. Wait. Yeah, okay, well, yes. Honestly, let me install Node version 12 locally. So that I can make sure my code runs against version 12, because that's what it's going to run against inside the virtual machine. Cool. So if I grab lowercase a, that's 97. So I need a for loop that goes from 97 all the way up to what is lowercase z, 122. And so this is going to give me every ASCII code from A to Z. And so I'll just say hexcodes.push i.toString 16. So that's going to convert that decimal number into a hexadecimal number. And then we want to do the same thing for capital letters. So we'll do capital A, so that's 65. And then capital Z is 90. And then we want the digits too. Yeah, I'm hungry gave it to us, but we'll just do it here. So we have 49. And then between, oh no, 0 would be 48. And then 9 would be 57. Okay. This is going to give us a bunch of hex codes. And then we're going to try every single one for every character in the password. Not don't invoke it, just return it. Good call. Inclusive, because we want from beginning to end. Okay. Just make sure this works. We need to actually call the function. Seems fine. There should be 26 times 2 plus 10 things in there. So is that equal to 26 times 2 plus 10? Yes. All right. we have all the hex codes. Very good. All right. Now, for every hex code, welcome in, Krinos and Cheetos. Good to see you all. Good to see you all. So we get all the hex codes and include curly braces because we know that in this case we specifically know that the flag is going to have curly braces on it. But this is really cool to see SQL map do this. It essentially found the injection point and then sent a bunch of requests to the backend to basically extract the entire user table, and was also able to extract like the information about the tables and like the schema and everything else. So that's cool. But we're going to do the same thing with just by making a bunch of requests ourselves instead of using SQL map. And we're really just porting this code that they gave us. So yeah, we're also going to try curly braces because we know that the flag is going to have curly braces in it. We want that, and we want that. Okay. And then we want to run this as our query. Yeah, I don't think we need those as actually, I think you're right. Yeah, we do need to make those ASCII numbers. You're right. You're completely right. Yeah, because our codes down here is going to cast them back to text. There's a try hack me room I'd love to see you do. The web portion is a little tricky, but when you get the root flag, the JavaScript surprise at the end is wonderful. Yeah, that could be fun. I don't know if I'm ready for like completely open rooms. There's a lot I still need to learn. But maybe if I know all does it list out what skills are required? Because if I make sure that I know all the stuff going in, then that would definitely be fun to do. Okay, so this is our injection attempt. We are putting the current character that we're working on here. So I'm going to make this a parameterized string. And we want to put the current value of I right here. So this is the current character that we're working on, given the password length. And then we're given that character, we are trying every single possible hex code. Cool, so this is our injection. Now we want to send the post request to the URL. Like this. Doesn't have to be charcode at close. Charcode at 0 gives us the ASCII character code, and then we need to convert it to hex. Yeah, you're completely right. I missed both of those things. we could get fun with it though. We could map it, get the character, and then do that to it. Cool. Yeah, okay. So now we need to make a post request. We're in Node version 12. I think isn't there a... I guess we might try using the HTTP module because it is just an HTTP request. Request character. You pass in the query. We essentially want to make a request here. And let me just look up my machine is going to expire. No! Cool. Node HTTP module request. I don't want to install any external modules, which is typically what we do. So I just want to figure out how do I make an HTTP request with the built-in model, with the built-in module. It's not going to be easy. And also because we're in Node version 12, we don't have access to fetch, which will also make it extra hard. Version 12, yeah. We could go grab the version 12 docs. That's what we need to do. We also could just install the latest version of Node, but this adds to the challenge, right? We want a client request. Okay. Request is an external module, though. We'd have to install it. So pull in HTTP, pull in net. I'm not trying to do client socket stuff. Come on. Create an HTTP request with these options. What? Okay. HTTP.request, I guess, is the method that we want then? No worries, TG Digital. We're still doing some stuff. Right now I'm trying to port a Python script. Okay, so this is doing a post request. Oh, do we have to set the content length header and everything else? That's ridiculous. Okay, we'll use the request module. I'm not going to. Actually, we could yeah, you don't think we do? Not for GET request. It has to. It's a post request though. Is the thing. It's a post request with a body. Yeah, we'll just use Axios. Because I'm not going to. I'm not gonna worry. Yeah. I actually I thought I wanted to. I don't want to. We're just gonna use Axios. Okay. Here's the thing, though. Is this version of Axios going to work in Node version 12? Let's see. Unexpected. It does. It works. Okay. Good. So now with Axios, we can make a post request. We can say. Also, do we have? I don't think. Do we have async await? I don't think we have async await. I'm going to assume we don't have async await. the data and then the config. Do we have a SQLI? Oh. All right. But the thing is, we do need to be this. We need this data to be form data. So you're right. We need all the info. We'll have I don't know what axios.post returns. Okay, make a post to this URL. And then do we just construct a query string? No, so the injection vulnerability is in the username field. That's why we're passing the query in here. Let's look up how to submit form data with Axios. Post requests. Form. URL encoded form data. Easy. This is why we use Axios. Yeah, that's what Merit Codes is mentioning. All you got to do is specify it in the headers. Like this. And then it'll automatically format it. Okay. Handling errors. What is a successful response? Is it a 200? Or a non-successful response? A non-successful response is a 200. Yeah, so a 302 is a successful response. This attack, I think, works. 302. So we want to look for a 302 response. Status. And then we're just going to return status is equal to 302. So if status is equal to 302, then that means we found a specific character. Okay. So we're going to make this async. The thing is, we actually don't have to request one character at a time. What we could do is password chars. Request all of them, and then it'll slowly fill in this array. Yeah, so right here is where we're going to say request char with that query. This would await it. Let's do it one by one. No, we can't do it one by one. That's going to be how many requests? The number of possible hex codes times the length. We'll do it one by one. Yeah, they're not rate limiting. Okay. If the result was true, we found that specific one. So we want to push it into the password characters. So we'll say password chars. We're going to push in result. Oh, not result. So the current code goes here. Code is a hex code. we'll turn it into a number. So we can turn it into decimal. The radix base 10. And then that is an ASCII code. So we want to say like string from character code. From char code. Is the default 10? I don't know. So get the hex code, convert it to decimal, convert that decimal ASCII code into a string. And that gives us a character. And then we can break out of this for loop because we don't need to try the rest of the characters. Let's do some logging. Let's say found character add incoming. All right. I won't run the code until the add is over, but I'm going to finish converting this because we're almost done. At this point, I just need to get the code onto the other computer and then run it. All right. See you all in 3 minutes. Oh, you're right. This isn't the way to convert it. Oh, I ended up updating that. It's over here. So yeah, we're passing that in instead. But yeah, maybe you're right here. So we have a hex code, which is a string. We want to convert that hex code to decimal. Maybe I'm not doing that right. Parse int is what we want, not toString. Yeah, so we will parse int this and tell it that it is base 16. That's what we want. Yeah, cool. And then after all this, we'll log it out. Cool. Yeah, that's it. Let me get my local environment set up. Wait, we have Node, but we don't have npm. I'm just gonna install nvm. Uh, Are we back from the ad? We're back from the ad. We haven't gotten it done yet. All right, we're gonna install Axios. Good. We are now going to edit a file called attack.js. We're gonna throw our codes into it and hope and pray. Don't do that. Okay. Now, moment of truth. Will it work? That's funny. It searching for the 0th character, found the 0th character. Searching for it just thinks the password is all curly braces. Awesome. Okay. First of all, if we know the length is 38, we need to go less than or equal to. That's one thing. We did not await the request character. That's why. That's why it came back as truthy, which is, yeah. So we need to actually wait for the response. And Ryan, thank you for the sub. So, yeah, we made this async. The thing is, and the thing to note is if you have an await inside of a for loop, it's going to wait for every single one. So this is going to be very slow. If this works, we could actually fire off tons of requests and just get it all like really quick. But here we go. I guess I don't know. This is a really inefficient workflow, but it's fine. Searching for the 0th character, we're going to hope that it finds the character T. If we don't see anything log and it does move on to the searching for the 1st character, then we know that it didn't work. It didn't find it. Okay. What could be going wrong here? I think it's possible that Axios follows 302 redirects, so we never actually see the 302 status code here. That's my first guess. Follows redirect. Max redirects? Set that to 0? Honestly, do we have VS Code on here? No. We do have a text editor, though. Yeah. The redirect means that we found a character, because that's the way the web app behaves. If the query we sent results in true, then that means we found that specific character. So I think if I just set this max redirects, yeah, this is Mate terminal. If I set that to 0, then it should not follow the redirect, and then the status code will be 302? Maybe? Let's see. Let's add some. Yeah, it didn't find it there either. Let's add some more logging code. Oh, thank you, Ryan. That's very kind of you to say. You said thank you for all you do. Thank you. Thank you for being here. Let's just log the status we get back here. Let's log it. Status. And honestly, to debug it even more, I'm just going to explicitly try with the letter T, because we know that the first character in the password is the letter T, and let's see what status code we get there. And we'll also debug the query that we're sending. But if we just say our hex codes is a single array with the value 54, 54 is the hex code for capital T. Let's see. Okay, that looks good. Status code 200, that's not what we want to see. Right? If we can double check, is this the correct injection here? Glad to hear it, Ryan. That's awesome. No. That didn't quite work. Wasn't 54 the for capital T? Did I mess that up? Let me just put my own little query in here. Okay. This becomes code. This becomes I. I think. How easy do you find it to pick up a new language to code? It depends. You can see me trying Rust from like 2 weeks ago. And that was all right. I mean, it was should I start at index 1 or 0? It should start at 0 because it's looking at this array of hex codes. It also should be greater than or equal to. We didn't update that. All right, I'm working on codes in 2 different places, which is not ideal. So let me get these 2 synced up, and then it'll be easier to debug. Okay. And then also we were doing this. As a beginner programmer, this is very confusing. I mean, this is also confusing to me. Like, once I get it working, I'll explain what's happening, but there's a lot going on. there's a lot going on. All right. Try again. Status code 200. Trying this query. Okay, that is also the wrong query. Maybe it's not escaping it in the right way? Did I put the wrong limit in there? Oh, I did put the wrong limit because it's we want the 0th user. Select password from users, limit 0th user, 1, substring, start here, and get one of them. Right? I have to look up the substring method. 1, 1. Okay. The other thing is it's not zero based. It's not zero based. It's not a zero based index, which means our J here needs to start at 1. We need to do J plus. Wait. Oh, and this needs to be J. This needs to be no, it is I, but it's I plus 1. Okay. That's our other mistake. All right. Request failed with status code 302. How was 302 a failure? 302 is a redirect? Is it because we have follow redirects set to false? Thank you. Cool. What did I just do? I got rid of the... Why was it trying so many times? Oh, it's going to try 38 times. That's why. This inner for loop should not be less than or equal to, because that is zero based index. That one's fine. But here's the issue. We want to get back a 302 error, so I think we do have to say max redirects is 0 and then try catch it. Here we go. Honestly, for this we could just try catch it. Yeah, we'll just try catch it. Here we'll return false, and then here we'll return error.response.status is 302. This should do it. We're in. Okay. Here we go. It's working. So it found the first character, which means now we can just search for all the rest. And we'll make it do it without waiting for every character. Yeah, there's other ways to do it. You could probably stop it from throwing an exception. We figured it out. This is good enough for now. Now let's request. Let's make thousands of requests simultaneously. Just. Okay. I'm going to have an array of promises. And we're going to push into that array this much. Wait. This is going to be a lot of requests. What I was thinking is we just push in like a dot then here. But this might, I don't think this is going to work because now we can't break out of the for loop. But that's okay, I guess. Just try everything. And we are using block scope, so our stuff shouldn't be weird based on the current promise that we're in. And we don't want to push. We literally want to say password characters at I equals that character. And then here we'll await all our promises. So we're going to fire off thousands and thousands of requests and then wait for all of them to finish. And when they all finish, our password characters array should have been constructed. My order of characters. Yeah, this is where I'm trying to fix the order of characters, where if it was successful, we know what I was. Okay. Let's see. All we can do is try. If this doesn't work, we'll just wait. We'll wait for the one that just will do one character at a time. You can see they're returning in a different order, right? That's fun. So yeah, it's firing them all off. They're all returning in a different order, but then when it's complete, we should have them in the right order. Yeah, what's up, Purple? I'm doing good. We had a slow start to the SQL injection episode, but I've been having some fun. Nice. Got it. All right. Let's just try it. And then if it was wrong, we'll have to update our code. Yeah. Ashley B. Oh, no worries. You can check out this article on how to set your handle. Honestly, on these messages, I might put both your handle and your YouTube display name because YouTube right now doesn't show your handle in the chat. It's super weird because YouTube shows your handle everywhere else on the website, but for whatever reason in the live chat, they still don't show your handle. But if you want to change your handle, you can do it here. It's the thing that gets displayed. This is fun. It was also fun to port a Python script. Okay. We need to Control-Shift-C this. Actually, let's do a prediction. Did I get the right? Did my codes work? Will the flag be correct? Yes or no? You have 30 seconds to predict on if I got this right. If not, somewhere in my code is wrong. You can set your country flag with exclamation mark flag followed by your 2-character country code. So this would be UK, US, wow, a lot of people are trusting that this is going to work. I don't even trust that it's going to work. I think, I guess one nice clue that this is probably correct is that it put the curly braces and the THM in the right spot. So, yeah, I have no idea what that flag is. Is it somewhere in Africa? Oh, Lithuania. Lithuania. We got Belgium, Lithuania, Netherlands. All right, here we go. Yeah! Yeah. I mean, it was good to say yes because if my code was wrong, it would have jumbled up the characters, right? Nice. We don't need SQL map. we can just brute force a server on our own. Like here's the thing to think about though. If the like how many requests we actually sent to the server, if the length is 38, yeah, that is true. Thank you, Varg. Thank you for the bits. Oh, not that. I just want to see what the length. So if we have 26 lowercase characters, 26 uppercase characters, 10 digits, and 2. So that's 64 possible characters of length 38. So 64 times 38. I guess it's not that many. We just sent 2,432 requests to the server in order to brute force the password. That's, in the grand scheme of things, that's actually not that many. Cool. This was fun, though. I had a good time. I'm going to put this in my notes. Oh, I have it in my notes already. Real quick, let me explain my codes for any of the newbies. Basically, on Try Hack Me, they already gave us a Python script that we could run. But I wanted to attempt to write the script with a language that I use daily, which is JavaScript. Yeah, definitely not the quietest solution. This just immediately fires off 2,000 requests. Yeah, if you do ! flag space clear, it'll remove any flag that you've already set. Yeah. But basically, I took their Python code and then just tried to write it with the JavaScript that I know. And ultimately, we were performing the same attack that SQL map was performing, which is we figured out that the post request on this page was vulnerable to this bit of SQL injection, where we can basically look at an individual character in the admin's password one at a time. And we, one at a time, can basically determine, is the inf character in the password the letter T? Is it the letter A, etc.? And so because this SQL injection works, we were able to just send tons and tons of requests to figure out what every single character in the password was, which ultimately returned to us this value. And so the codes for it were not too complicated. Ultimately, we generated a list of all possible hex codes. And yeah, I'll pay out the prediction. I mean, almost everyone predicted that it would work, but yeah. Yes. Yes. Cool. All right, I'm going to end it there, but in future weeks, we're going to do the rest of these tasks. It's gradually getting more and more complicated. I'm guessing we'll have to use a whole lot more SQL map. We'll learn about other kinds of injections, but that'll be a good time. Cool. Yeah. That's it for today. Let me tell you all about what's up next and everything else, and then we'll get out of here. So follow me over on YouTube if you haven't yet. And if you're watching on YouTube, follow me over on Twitch. We are going to go on a raid after this. So, and thank you, Ryan. Thank you for the bits. Appreciate that. But if you want to join, if you're watching on YouTube and you want to join the raid, click that link. I'll be streaming again. That's a great question, TG Digital. Check the schedule. So the plan is to go live on Friday for a Tri-Day Friday. Hey, no worries, Ashley B. I hope you enjoy the VOD, but yeah, no worries. Right now I have a fairly consistent schedule, so I have been streaming I guess last week I didn't stream on Monday, but ideally every Monday, Wednesday, Friday at 11:30 a.m. Mountain Time. Potentially, yeah. So if you check out the calendar, I will be live on Friday for Try-Day Friday. And last week we tried Laravel and PHP. The week before that we tried Rust. The week before that we tried HTMX. You all will decide what we try. Right now, Godot is at the top of the list. And Java Spring Boot, and then also like something .NET related or machine learning related. All of these are at the top of the list. If you want to suggest Django, we can vote on that too. So basically, at the beginning of stream on Friday, we will vote on what we're going to do on Friday. And I'll have a link in the chat on Friday for you to vote on. And we'll potentially add new suggestions to the list if at the beginning as well, because this isn't the definitive list. This is just some of the suggestions that we've got. So yeah, tune in on Friday. You can find the schedule over there. And also go follow me on Twitter. I also have a mailing list if you want to get go live notifications there as well. A few people mentioned that they didn't get the notification today. If you're on the mailing list, you should get the notification. It was going to spam for a little bit, but I think I fixed that. So if you join the mailing list, I do send out a go live notification there. We also have a Discord if you want to hang out over there. And that's all for today. If you're looking for something to do after this, go over to my YouTube channel. You can watch a bunch of the recent streams that we did. Like you can look at like last week where we did cross-site scripting, or last week where we tried PHP. Go check out my YouTubes. I've been coding, I don't even know at this point, over 10 years, but it might be over 15 years at this point. I've been coding for a very long time, very long time. Actually, this is another spot you can go after the stream. Check out the frequently asked questions. It's like a novel if you want to learn about the coding garden. But there is a section here. How long have you been doing this? How did I start live streaming? Am I self-taught? How long have I been I've been coding for over 18 years? That's that's a long time. But yeah, let's go on a raid. If you are a sub, you can use this raid message. How do I stand with AI and Copilot? Or where do I stand? It's fine. I don't have a simple answer for you because it is fairly nuanced. Thinking about the fact that like Copilot was potentially trained on non-open source code bases, and the fact that when you're using it locally, it's potentially sending the code that you have locally to remote servers. So it's not ideal if you're like using it at a company or something like that. But in terms of using it, I think we should all learn how to use it because eventually that's going to be a lot of how we code things. So that's my stance on it. It's like I guess a necessary evil in a way. But here are the raid messages. Let's go on a raid. I don't know who we're going to raid, but whoever we raid, show them lots of love. Drop a follow if you like what they're doing. All that good stuff. Alrighty, everyone. Hope to see you on Friday. But until then, wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.